Okay, today we're talking about percentage composition again, but instead of calculating percentage composition from a formula, we're going to start with percentage composition and try to get back to the original formula. Now, I've outlined some steps, 1, 2, 3, 4, and I'm going to go through those steps one by one and explain how to do this. If you will follow this plan, it should be fairly easy, and we'll just go ahead and get started. So the first thing we want to do, we have a sample that is 83.6% carbon, 16.4% hydrogen, with a formula mass of 86.17 grams per mole. So how would we actually get this back to an actual formula? And let's start with step one. It says number one, assume 100 grams. So what we want to do is assume that our sample size is 100 grams. And if that is the case, then that means 83.6% carbon. If it's 100 grams, that means you would have 83.6 grams of carbon. And of course, by the same convention, you would have 16.4 grams of hydrogen. Okay, the next thing we need to do is to convert this to moles. So just using the method that you've already learned, you'd say 1 mole of carbon is 12.01. Take that brush size down just a little. 12.01 grams of carbon. And hydrogen, 1 mole of hydrogen is 1.008 grams of hydrogen. And of course, we multiply or divide that out. Units cancel, and we come up with 6.96 moles of carbon, and then 16.3 moles of hydrogen. Okay, step 3, divide everything by the smallest number of moles. So, okay, in this particular case, 6.96 is smaller than 16.3. So we're going to divide everything by 6.96. Of course, this one equals 1. And then this one's going to equal 2.34. All right, the next step says round numbers that are close to whole numbers. Well, 1 is 1, but 2.34 is not really close to any whole number. So we have to figure out what to do here. If you look at this part of the number, you'll notice that that roughly looks like it's about a third, right? 0.33. So let's see what happens if we multiply everything by 3. So if we do that, of course that's 3, and this one becomes 7.02. Now, let's look at step 4, round numbers that are close to whole numbers. Well, 7.02 is close enough to 7 to assume that that 0.02 just comes from some sort of rounding that we've done. If we had probably many more significant figures, it might come out to be 7.000 or 6.9999. However, due to whatever rounding we did, it might not come to be exactly a whole number. However, subscripts have to be whole numbers. So we'll go ahead and round that to a whole number, and then we'll put down here C3H7. Now, this is what we call an empirical formula. What that means is that it is the lowest whole number ratio of all the atoms. Now, is that the same as the molecular formula? Well, possibly, but possibly not. So what we need to do is we need to get the molar mass of this and see what it looks like. And so if we just do 3 times 12.01, and then we're going to add 7 times 1.008, and if we add all that up, that's 43.086 grams per mole. Okay, let's compare that back to our original number up here. No, it's not the same. As a matter of fact, it looks, just by looking at it, like we just simply need to multiply everything here by 2 to make it equal this number. And so let's do that. And that's going to give us C6H14. And that's going to be our molecular formula. Oops. Okay, so that's how you go backwards. That's probably one of the more, you can have more elements, not just 2 elements, you can have several elements, but that's probably one of the more complicated ones that you would see, simply because you don't always have to multiply by 3. So hopefully this helped you out. If you still have questions, please let me know.